Okay, so after a string of mishaps, including losing this little piece here, and I'll show you how not to do that, when you are removing the stock flapper arm, the follower, from the blaster, the spring is right here, and it's under tension. So make sure that you remove the barrel before you try and pry the flapper arm off. So that's the first thing. For the want of this one little part, which is going to turn up eventually, I had to crack open a new blaster to cannibalize the spring. Okay, so the piece here is what kind of needs to be modified if you want to try and squeeze an extra ball into this rather short feed tube. And what happens is it impacts the barrel, because this is in here, right there. So this needs to be shortened, and this giant little cup thing doesn't need to be this large. So you can remove most of that. The problem is if you mess that up, or if you just start shaving away with the Dremel, you can compromise the structural integrity of the piece if you shave too much plastic, and it can break or fail. So ideally, you want to be able to start with a piece that you can just print another one of. And in comparing the two, you can see just how skeletonized the replacement part is. And the cup has been replaced with this little tiny arm that provides just enough surface area to push the ball through the chute, which you'll see shortly when we install this. And this simple little piece right here, which if you look at the stock piece, it does have quite a bit of geometry going on in here, and none of that is really superfluous. So in trying to get something that fits, functions perfectly, these are all different versions of the same piece that had to be printed on the road to getting this single piece right here. Usually it is not this this difficult, but this piece right here was testing my patience to the degree that I wanted to finish the design just because it did not want to be finished. that is not such a thing. Reality doesn't work like that, but I had a lot of difficulty getting this piece to work and fit properly. So if we can finally get this thing in there and it functions smoothly, there's no sticking, no jamming, it functions like stock performance, but with that extra ball in there, then it's still not worth the time and effort, but it will mean defeating a problem that did not want to be fixed. So if the piece works and I'm satisfied with it, then it'll be up on Thingiverse along with the other Kronos upgrade parts that I've already done. And I guess you can enjoy that. We'll do a little demo here with the 6-shot clip loader in a second once we get this all screwed back together. Okay, so the fit and function test. When you're testing this thing, you can't test it in the opened position because it looks like it works fine. And I can tell you right now, a lot of the previous versions of this same part worked okay here without having to shave down additional tolerances. And we are talking about less than 1 millimeter tolerances to get everything to fit properly. But until you assemble everything together, you're not going to see whether it clears this little rib that they put in there. I think that's just supposed to be structural support, but it also puts a restriction on how thick the support arms can be. And this bit right here dictates how far back it can swing. Now, if this is a little bit taller, then it can stop the arm from going any further than that. But by shortening it, now we can see that it will extend a little bit further. All right, so let's get this thing together and let's check it with some 6-round stripper clips and see if we've got a winner this time. All right, so this is the half shell assembly. So all the pieces are in place. We just need to close up the other half of the clamshell, and you can see that we get free action here, and the arm will go until it impacts the plate. So it'll probably be a tight squeeze, but I think we can get 6 in there and get it to feed reliably. So it's A and B. Getting 6 balls in there isn't that big of a deal. If you have to push really hard to get that in there and you have to jiggle things around to make sure that doesn't feed 1.5 balls into the tube, it has to work smoothly. That's kind of the absolute consideration to make this even worth using. Okay, so everything is buttoned up, and you can see for yourself that there is the pusher needle, pin, whatever you want to call it, but that's what replaces the cup. And it works with both the older style unidirectional clips. So you can see there's 6 balls in there. And feed is actually easier than the stock piece, if you can believe that. And that was 6. And again, 6. Old style stripper clip. Feeds in pretty easily. The unidirectional or omnidirectional updated version. One more. Didn't push that one in all the way. But you can see just by taking a look at it that it's not jammed heavily. It actually fits in fairly comfortably. All right, we'll do one more. I want to say that the unidirectional ones feed a little bit better due to the flat. So the same thing that keeps it from being able to, well, I guess I could I could adjust this lip so that it's more like the updated version of the lip, which doesn't have as much grab. Because you can technically push balls through there. It just takes a lot more pressure before it pops out. Whereas this side, they come out quite easily, which makes them easier to feed into the chute. Like so. But it definitely works. I haven't chronoed it. I also put a little spacer in there, but something like a spacer is something that anybody can do in about a minute in any 3D modeling software. So the arm was the piece that was really harder than I had hoped for that one extra shot. But it does complement the 6-round stripper clip, so not all is lost. For some reason that one didn't want to, oh, you know what it is? All right, so when you print this, if you use that's the other advantage of having the flat bottom, is that you can print these without using a brim. Now, if you print these omnidirectional ones with a brim to keep it from sticking, because the contact point is so thin that it's very easy to knock them off the build plate, unless you're using some really strong adhesive to keep it from falling over. The little tiny bit of the brim that's on there, and you can just kind of file it off, will make that resistance a little bit harder as you're feeding the balls in there. So I've noticed that on the top side, which has no brim, that feeds smoothly, but when you try and feed it the other direction with the brim side, then it is a little stickier, which kind of defeats the purpose of having a omnidirectional stripper clip. So that's more of a issue with printing than it is with the design. So if you do use a brim, then you're going to file the inside out to make sure that it fits smoothly. So here, this is the smooth side, this is the rough side, and let's see, let's clear this out. So smooth side in, and still having issues. What's going on? Well, I think right there on camera, I may have made a good argument for the unidirectional clips. Somebody might ask, why bother with the unidirectional if the omnidirectional is better? Well, there's your reason right there. The unidirectional with the flat bottom, it makes loading easier than the omnidirectional. But I'll leave that up to the whoever it is that's making the prints and how they play. I'm just going to say that the unidirectional ones are a little bit easier to work with when it comes to reloading. So this is a little bit less than this. But they both work. You just saw that one is a little easier than the other. So that's it. 6 round and no chopping. We just replace the stock flapper arm follower piece with the customized version that I will have on Thingiverse so that you can do the upgrade installation yourself.